Hello, welcome to chapter 7, lesson 2. This is our week 14 lesson. In this lesson, we are going to discuss about property of exponential function. At the end of this lesson, you should be able to draw the graph of exponential function, translate parent function, evaluate e to the power of x, and you should be able to calculate a compound interest. Now let's see the lesson content. On the first point, we are going to discuss about a key concept regarding the families of exponential function. Then we are going to practice drawing the graph of y is equal to ab to the power of x. Then we are going to see uh, how we are going to translate the parent function y is equal to b to the power of x. Then we are going to practice evaluating e to the power of x. Then finally, we are going to discuss on how to find the continuously compounded interest. At the end of each solved problem, please don't forget to practice the guided question from your textbook. Now let's go to the key concept. Families of exponential function. Y is equal to b to the power of x is a parent function. Now we can transform this parent function to different kinds of exponential function. So when we transform it, we are forming families of exponential function. For example, if you multiply by a positive integer, the parent function, which means you are stretching vertically. If you multiply by let's say a, which is a positive, you are stretching vertically by a factor of a. And if you multiply by a value which is between 0 and 1, you are compressing vertically. And if the value of a is negative, which means that you are reflecting the parent function b to the power of x across the x-axis. The next one is the translation, which is horizontally or vertically. If you add or subtract on exponent or on x, you are either moving horizontally to the right or to the left. And if you add on the value of b to the power of x, whether it can be positive or negative, you are moving either up or down. So this is a translation either horizontally or vertically, depending on the value of h and k. The last point is y is equal to a times b to the power of x minus h plus k. This time, this one of the family of exponential function which contains all the combined translations. That means it has uh, stretching or compressing, it has moving to the right or to the left, and also it has the vertical shifting either up or down. So these are some of the families of exponential function. Now based on this key concept, let's see some problems. Okay, problem 1 is about graphing y is equal to a times b to the power of x. How does the graph of y is equal to negative 1 over 3 times 3 to the power of x compared to the graph of the parent function? Okay, by the way, for this function, this is one of the families of exponential function, the parent function will be y is equal to 3 to the power of x. Now when you see this function, as you can see, uh, the parent function is multiplied by negative 1 over 3, which means that it has two kinds of translation. One is stretching, sorry, it is compressing because 1 over 3 is between 0 and 1, and also you are multiplying by a negative value, which means that it has reflection. Anyway, to compare the graph of y is equal to negative 1 over 3 times 3 to the power of x to the parent function y is equal to 3 to the power of x, let's draw the graph of y is equal to 3 to the power of x and y is equal to negative 1 over 3 times 3 to the power of x using a table. Now prepare a table, okay, for each of them and choose some values of x. When you choose some value of x, please include the negative values, 0 and positive values. Now we have some values here. Then let's sketch the graph of each of the function. Now this is the graphs for each of the function. The red one shows the graph of y is equal to 3 to the power of x, and the blue one shows y is equal to negative 1 over 3 times 3 to the power of x. As you can see, the graph y is equal to negative 1 over 3 times 3 to the power of x is a reflection. It is a reflection of y is equal to 3 to the power of x across the y-axis. And as you can see, the blue graph, it moves away from the y-axis. That means you are compressing by the factor of negative 1 over 3. So we can say that graph of y is equal to negative 1 over 3 times 3 to the power of x is a reflection of y is equal to 3 to the power of x across the x-axis, and it's compressed by the factor of 1 over 3. And the domain and the asymptote will be remain the same. Okay, that means the asymptote is the x-axis. As you can see, the two graphs will not touch the x-axis, which means that the x-axis is the asymptote of the graph, or y is equal to 0 is the asymptote of the graph. And the range for the first one is the set of positive integer, the set of all positive real numbers. But for the graph of y is equal to negative 1 over 3 times 3 to the power of x, the range is y less than 0. Okay, so in this way that we can compare the graph of each of the function. This problem 1. Let's go to problem 2. Problem 2 is about translating the function y is equal to b to the power of x. How does the graph of the function compare to the graph of the parent function? This is the graph, or this is the function. Y is equal to the power of x minus 4. Now, like we said in the key concept, if you are adding or subtracting on the value of the exponent or in the value of x, which means that you are either moving to the right or to the left. If you're subtracting on the value of x, which means you are moving to the right. So in this case, you can say that y is equal to the power of x minus 4 is the horizontal translation of y is equal to the power of x to the right 4 unit. Okay, so to make sure, you can check it by drawing the graph of the parent function. Okay, so the parent function is y is equal to the power of x. Okay, just like we did in the problem 1, just choose some values of x. When you choose positive values, negative values, and 0, and plug each values of x into the value of y is equal to the power of x. Then you will get the value of y, then draw the graph of the power of x. As we said, translate this graph, the parent function, 4 unit to the right, then you'll get the blue graph. The blue graph shows the graph of y is equal to the power of x minus 4, and the red one shows the parent function y is equal to the power of x. So the x minus 4 in y is equal to the power of x minus 4 translate the graph of y is equal to the power of x 4 unit to the right. In this case, the asymptote will remain the same, which means the x-axis, or y is equal to 0, and the y-intercept, that means the point where the graph crosses the y-axis, will be changed. For the parent function, the y-intercept is 1, that means when x is 0, y is 1. But for y is equal to the power of x minus 4, the y-intercept will be 1 over 16. So problem 2 is about translating the parent function y is equal to b to the power of x. Let's go to problem 3. Problem 3 is about evaluating e to the power of x. To evaluate e to the power of x, we need to use a calculator. For example, evaluate e to the power of 3. Definitely, you will use your calculator to evaluate this value. So what you need to do that, just use the key e to the power of x, and press the key 3. Then you will get the value, which is approximately 20.085362. You can use graphical calculator, and you can use any scientific calculator to evaluate it's the perfect. This is problem 3. Now let's go to problem 4. Problem 4 is about calculating continuously compounded interest. There is a problem in your textbook. I think it's problem 5. Uh, Suppose you won a contest at the start of 5th grade that deposited $3,000 in an account that pays 5% annual interest compounded continuously. How much will you have in the account when you enter high school 4 years later? Express the answer to the nearest dollar. Now, the first thing that you need to do that you need to know the given information. Here we have a $3,000. This is initial deposition, or this is a principal, and there is the interest is 5%. So we have the interest, and we have the time 4 years later, which is the time is 4 years. And what you are asked how much will you have in the account after 4 years. That means you are asked the total amount of money that you will get after 4 years. So to find the compound interest, there is a formula. We need to use this formula. Formula is equal to T times e to the power of r times t. A is the total amount that you will get, P is the principal, and R is the interest rate, and T is the time. Then just plug the given information into the formula and simplify it. And finally, you'll get 3,664. So this is the total amount that you will get after or later 4 years later. So this is about lesson 2, chapter 7 for week 14. For more practice, we can have more discussion on live on our live class. So please prepare your question so that we can discuss in our live discussion. So this is all about for this week. Thank you very much and goodbye.